Okay, hello and welcome everyone. So this video is an extension onto some previous videos that we have done, but in particular what we're looking at is one area of PLC programming where essentially we have a decision tree that is happening within the PLC task. So the PLC is making a decision based on some sort of circumstance, whether it's going to run one sequence or another sequence. So sometimes we call it branching or subsequences or things like that. But essentially what's happening is the PLC, although we have a sequential task, it essentially has two sequential tasks within it. So depending on some sort of circumstance, the PLC will either run one sequence or another. Okay, so hopefully that makes sense. Um, what we're just doing is we're coming off on the back of this question here that I used in a previous couple of videos. And we have the PLCs running this sequence here. So it's a sequential task and its main sequence is A plus, B plus, A minus, 5 seconds, B minus, A plus, A minus. And what I'm going to say is I'm going to change it slightly that if A takes longer to extend, so let's say its normal stroke length is 3 seconds. Let's say if it takes longer than 3 seconds to extend, instead of running this sequence here, we're going to run a different sequence. And what that sequence is just going to be, it's going to be B plus B minus, and then A minus. Okay. So what we're actually saying is the system can either run this sequence or it can run a different subsequence depending on how long A takes to extend. So if A takes longer than 3 seconds to extend, it will run the subsequence, which we're saying is just going to be B plus B minus A minus. If A takes less than 3 seconds to extend, it will be A plus B plus A minus 5 seconds, B minus A plus A minus. It'll be the normal sequence. So hopefully you get an idea of what that the question is asking here. Now, when we come into it, the numbers can be useful to us. And what we're essentially saying is, okay, let's just say this is our normal numbers here, our normal main sequence here between 10 and 60. But what I'm going to do is my subsequence is going to be in a range of, let's say, 200. So I'm going to do 210, 220, 230. Okay. And the move block that we have within TIA Portal allows us to, move to whatever number we want. At the moment, we're just moving very much sequentially. So we go from one step into another and next, and we're going up in groups of tens. But there's no reason why we couldn't jump to step 200 and then jump back to step 10, jump to step 70, jump back to 30. You can move whatever way you want. And that gives us a powerful setup to do this sort of subsequence depending on a particular circumstance. So I hope that makes sense. Now what we have set up the code to run that main sequence at the moment. Okay, and as I said, we did that in another video, so we have it running this. So essentially what I want to say is, well, in this step here, I need to monitor some event that happens, and then if it isn't a normal event, I need to move it to my new steps of 200. So this is where this decision tree comes in. So essentially this is all happening in um, in steps in step 10. And what you can see is I put a branch down here because we're going to do something different. So at the moment, in step 10, if we hit AL1, we'll move to step 20 and we'll continue with our normal sequence. But now we're going to say, well, if something else happens, what we're going to do, instead of going to step 20, we're going to jump to steps 200 and run a different sequence. So what I want to put in here is just a timer. We'll just call this, I'm not quite sure what number I left my timers on, but let's go with timer 2. Okay, I can actually see in here where my timers are. Okay, that's timer 2. And let's just say I go 3 seconds in here. And let's just try and understand what this decision is now telling me. it's basically saying in step 10, okay, if you hit AL1, go to step 20. And in normal circumstances, that should happen less than 3 seconds. Okay? But what we're saying is, well, if we actually timed up to 3 seconds and this wasn't triggered, we were going to go into step 200. So on normal setup of our double acting cylinder, if it's moving forward, it will hit this within 3 seconds. But if not, this pathway is going to get evaluated first. So if it takes longer than 3 seconds, it's going to go into step 200. And this is our decision tree. Happens on this side. It's not so much kind of branching and latching, which is happening kind of on the left. We're branching out towards the right. So we're given it two options that in step 10, depending on some condition, depending on how the speed of the system is moving, the speed of the cylinder, it will either go to step 20, which means it just continues on from here, or it'll go to step 200. So I'm hoping that makes sense, and that's really where the main kind of complexity comes into it, because then what we can do is, well, we can go down here and we can call this subsequence 200, and then we just code our system sort of the same way. So I can copy this in, and we're now saying from 200, okay, what do we want to happen, okay? So we said, well, if this is still moving forward, we're saying if that takes too long, what we're just going to do is B is going to go out, B is going to come back, and then A is going to come back. So we want B to come out first, so BL1, and then that will move us to 210. So we want B to come out, then in 210 to 220, B then comes back, and then the final step for that would be 220 to 230, be A to come back. Okay, and actually when A comes back, then we can go back to step 0 and start our system again. So then we got to just add those outputs in. So B has to come out in step 200. So B will then extend in steps 200. Then it will retract in 210. And then we also need A to come back in 230. Because essentially what it'll be doing is it'll be starting in 10 and coming back in 230. So this is the same in both sequences, but depending on which sequence we're running, if we're running the normal sequence, it'll finish with this. But if we're running the subsequence, we will do B plus, B minus, A minus, and then back to the start. And that's really all that's to it. It's identifying where the decision needs to occur, then trying to code in the two possible subsequences that could be run or the circumstance that will do that. So if we just hit the sensor less than 3 seconds, this will finish first. So then it'll just continue on with its normal sequence. But if it takes 3 seconds or more before we hit this, well, then it'll move to step 200. And what it does then is skips all these lines of code. And it, skips all these lines of codes and brings us to here, to this point, and it finishes these 3 lines, which just check that B has gone out, B has come back, and then A has come back, and then it goes back to the start. And we've added those outputs in as we see fit. So I hope that makes sense. A really powerful setup, and you could do that. You don't just have to have 2 subsequences in your decision. You could have 3 or 4 or 5. And it gives you a lot of flexibility in how you move through your system.